that multiply to 56. So I write it this way, multiply to 56, but they also have to add to minus 15. And you're correct. 7 and 8 multiply to 56. You got it. Okay. But they do not add to minus 15. Okay, they add to positive 15. So the only way to get this to work out is for both of these to be negative. -7, -8. And that's what you write as a binomial pair. Okay, now is your final multiple choice for your response? Do you know? Okay.
Yeah.
So where you got to be careful is, I mean, you do have the right answer. Like, that's not in question. The issue I have is that, like, would you be able to replicate it on an exam? I'm not sure. But you said each of these equal to 0. And in a multiple choice format, all the possible answers will be there. Okay, so x equals 7, x equals 8. Like that. All right. So I'd like to give you one to try like this. Do you have any questions on this?
No.
X squared minus 12x plus 30 equals -2. So go ahead and solve it. Give me your final answers, please.
So, minus 12x plus 30. So wait, oh, I put 30. The answer was 32. Power minus that plus 32 equals 0. And then 32, 1 and 32, 2. Two and 16.
You need any help, a hint or anything like that?
It's what's x equals 8 and x equals 4.
It's very good. It factors in x minus 8, x minus 4 equals 0, x equals 8, x equals 4. Really good. Really good here. Okay. The other kind of problem you might see is another type of factoring problem. Did you have some factoring earlier on the review assignment prior to this?
Check.
Oh yeah, it's on the next page. So
Okay.
we do have it. All right, good. So I was about to give you another one. We'll get to those. We'll just keep going here. All right. So next thing is problem like 38, which you have correct, but I don't see any work. Which,
I don't work for a lot of them.
yeah, that's okay. Like multiple choice answers, you just gotta get the right answer. SAT, ACT, I teach that. I say, just get the right answer. It doesn't matter how, but I'm concerned maybe if I asked you to do it now, would you be able to tell me how to complete the square, or would you like me to show you an example?
I remember doing it in class, but yeah, you can show me an example.
Yeah, so let's work through this one together, and then I'll give you one like it. So first thing you do is you subtract 53 from both sides. You always want that constant to be on the other side of the equation. X squared plus 16x equals minus 53, like that. All right. So now, just like we were doing earlier, you have to take half of this number half of 16 and then square it. Can you tell me what that becomes?
8 and then 8 times 64.
Plus 64 plus 64. All right, and this thing on the left is actually what's called a perfect square trinomial. That's part of the whole completing the square thing. So you end up writing as x plus 8. Notice the 8 is because you're cutting the 16 in half. That's where that comes from. Is that okay or not? Or do you want some explanation on that? Like this up here becomes this down here. Sorry, go ahead.
Okay. Yeah, that makes sense.
Okay, because you're gonna have to do this in the next one. I don't want you to say I have no idea.
Yeah.
The 8's half of the b, or half of 16. On the right, you just add them up. Minus 53 plus 64 is 11. And then you subtract 11 from both sides. So you basically move it back to the other side. And you have x plus 8 squared minus 11. And then you bring the y back down from earlier in the problem.
I'm just writing it down right now. So if I do need help, I have it.
Yeah, it's there's a lot of words that go along to each line. There's not actually a lot of difficult math. You know, dividing and squaring is not difficult. Adding and subtracting is not difficult. It's just putting it all together.
X2 plus 16. X plus 64 equals 2 plus 64. All right. You can go into the next problem or whatever
Sure. Yeah, so there's a bit more to this, and if you notice, if you're the problem there, it says to name the vertex on the y-intercept. So this is important here. What I'm writing in blue is considered vertex form, and the vertex is h comma k. Okay, so the in your problem, the hk is -8, -11.
-4.
Do you remember from class why it's -8 and not +8?
Because you flip the,
Yes,
yeah, do you flip the sign or whatever, or the,
but only for the first one,
yeah.
not the second. So that might be something to write down in your notes, flip the sign, so you know. Because guess what? On a multiple choice, all the possibilities are going to be there. 8, -8, 8, positive 11. They're all going to be there. So make sure you're solid on that. And I'll give you a few more examples to try, but.
Okay.
All right. So the second thing that they're asking for, that's thing one. Thing one is the vertex. Thing two is the y-intercept. So thing two here, y-intercept, you're putting x equal to 0. You're putting 0 in for x. So you rewrite the equation, but instead of x, you put 0 in. So again, that might be something else to put on your note sheet.
X equals 0.
Yes.
0. All right. And then wait.
Could you try simplifying this for me, please? 0 plus 8, then squared minus 11 for operations.
Wait, wouldn't it be just y equals 64 minus 11?
Yes. What is that? What does that equal?
Y equals 53.
50.
Is it not 53?
Yes,
Oh,
50,
yeah.
53. Okay, sorry, maybe didn't hear. All right, very good. All right, now we're gonna do another problem like 38. So I'm gonna gonna snip in the instructions, gonna do that. We're gonna do the same things again, but I'm gonna make up a new completing the square problem. So it's y equals x squared plus 8x plus 6. Okay.
So
Now you said you wrote some notes down. Do you remember the first thing that we did to complete the square?
divided by the x, like the 8x by 2. Oh wait,
After you move the constant over, you have to move the constant over. It will cause you problems if you don't. And then, I have the colored digital ink here. If you have a highlight or something, you just need to make a space and say, I got to put the same thing in both boxes. And it's exactly what you were about to tell me.
You divide the x by 2, and that gives 4 to the power of 2, which is 16.
So you put a plus 16, plus 16. All right. The next line is to figure out what goes in the binomial squared here.
Is it x plus 4?
Yes. Equals 10. Now you subtract 10 from both sides. And you bring the y down. Y equals x plus 4 squared minus 10. I'd like you to tell me the vertex, please.
X plus 4, 2 minus 10. HK. 4 and negative 10.
Do you have a note on your card or sheet there that says to flip the sign?
Oh, I didn't put that on my worksheet. I put that on my action. Okay, let me write that down.
So try that one more time here. Give me the vertex whenever you're ready.
Negative 4 and negative 10.
Yes, good.
Where is this one?
Now the next thing is the y-intercept. What do you have in your notes for the y-intercept?
Oh, is it we switch the x for 0?
Put 0 in for x, yes. So y equals 0 plus 4 squared minus 10.
Zero plus 4, 2 minus 10. And then it just, then you would, oh, then it's 16 minus 10, or y equals 16 minus 10.
So what's the final result?
Y equals 6.
You got it. Good. You want one more of those, or do you want to move on to the next type of problem?
Sure.
Okay. We'll make it too difficult here. Let's go y equals x squared minus 6x plus 4. So what I want is just the completed square. And if you have questions, you're welcome to ask, but try working that out on your own, please.
X2 minus 6x plus 4 equals 0. Minus 4 minus 4. So equals x squared minus 6x equals y2. Plus 9 equals negative 4 plus 8.
Are there any questions I can answer on this one?
Hold on. And then it's the vertex. Wait, you want the vertex? You want like the final answer?
I just want the completed square. I'm basically looking for this line right here that you did in the previous problem. After you complete the square, move the number back over. Or you can give me the vertex too, but
Yeah, I'll give you the vertex because I just got to that part.
okay, what is the vertex?
-3 and -5.
Okay, so is this what you're completing the square looks like?
Yeah. Oh wait, no, I have -5.
Okay.
I probably
Let me
messed up
check.
somewhere.
No, it is -5. It is -5. You were right on that. I made the mistake, but the vertex is not correct.
Oh, it isn't.
Nope.
Is it not -3? Because it's.
Oh,
Oh,
you
it's.
flip the sign.
Oh, okay, yeah. I wrote it wrong. I had never mind. You're right. Okay, yeah,
Okay.
it's +3.
Good. And then did you do the y-intercept? If not, let's do it real quick.
No.
Okay.
0 -3. 2. -9? No, wait, 5, 6, 8. -8. Wait, I don't think that's right.
You're putting 0 in for x. 0 -3 squared -5.
Oh, it's 9 -9 minus.
Yes, it
4.
is not. It is not. Yeah, it is 4.
Okay.
Good. Okay, good. All right. So we're not gonna do 39 exactly. We're gonna just give you all the transformations kind of so that you can see them all. So here, this is 39, and you're right. You have the right transformations. This one is right 5 and down 2. And it might even be worth putting the vertex in here 5, -2 each time. Okay. Now let's say it was x +3 squared -4.
Up
This
3.
one is left 3 and down
Oh, yeah,
4.
that's what I meant.
What
Left.
is the vertex on this one?
Is it not? Oh, 3.
Try again.
-3.
Yeah.
-4.
Okay, good. All right. So here's another one. Let's say it's x -1 squared +2. This is right 1 up 2. Can you tell me the vertex of this one?
1 +2 or 1 +2.
Yes. Good. The last possibility here is x +4 squared +5. Left 4, up 5, -4, -5. All right. So what you might want to have is 4 examples of all the transformations, or really clearly that when it's a negative inside parentheses, that means right. When it's a positive inside parentheses, that's a left. Somehow you have to get that down so you got it.
I have on my worksheet, on my final exam formula sheet, I have if it's on the inside, it's left positive, negative right, and then number on the outside is positive up, negative down.
Good. Okay. All right. So some comments I'll make on 40. It says to graph the function by identifying the vertex and the axis of symmetry. What you could do is you could complete the square, which we've done a couple of times. Most students don't do that. When it's in what's called standard form, this one's in standard form, ax squared plus bx plus c. A, b, and c are the numbers in front of x squared, x, and the constant. To find the vertex, you use a formula, -b/2a. Now, I'm not seeing that in your work. This would be a good thing to put in your notes. This is standard form.
Oh, wait. Standard form. I think I have f of x equals ax2 plus bx plus c. I have that. Yeah.
Good. Do you have the vertex though as well?
I have x equals negative b over 2a.
Fantastic. Okay. So now we go to your problem here, and you have to tell me the value of A, B, and C.
A is, wait. I think I thought I had that somewhere. A is 1. Wait, no, A is 1, right?
It is 1. It's the number in front of x squared, which is a
So
1.
then B is 6, and then or
It
negative
is
6,
-6. Yeah,
and
that's
then
C.
C is 3.
Good, really good. Okay, could you calculate the minus B over 2A for us, please?
So that would be 6 over 2. 3.
So what does that become? What's the result?
X equals 3.
Okay. All right, now that is the first part of the vertex. So that number is part of the vertex. So you've done half the answer. Okay, now to find the other half, find the y value of the vertex.
Do you substitute 3?
Yes. Back in. So would you try that and just confirm the answer?
Y equals a, no, so y equals 1, 3 plus negative 5, 3 plus, let's see, 3. So that's 3, y equals 3 plus negative 15 plus 3. Oh, no, so what is 15 like? Is it 9?
It is 3 squared minus 6 times 3 plus 8.
Oh, I didn't
Sorry,
square it.
plus 3.
That's why I didn't square it.
Yeah, you have 9 minus 18 plus 3. It is not 9. Give it another look.
No. Negative 6.
It is -6. Good. That is your vertex. 3 comma -6. Good. Do you want another one like that to try?
Um,
Or do you think you have it?
I have it.
Good. Okay. All right. So 41. Let's give you some more information so that if you get one like this, you know what to do. To find the domain, you take the part under the root. You ignore everything else, just the part under the root. 3x minus 10. Then you make it greater than or equal to 0. So you set whatever is under the root greater than or equal to 0, and then you solve for x. How do you solve this for x? How do you undo this here? How do you undo this here?
You wait. Would you add 10 to both sides?
Yes, exactly.
And
The 3x is greater than or equal to 10.
10. And then you divide by 3. maybe?
Yes. Yes, exactly.
And you get x equals
X greater than or equal to.
wait 10. 9.3 repeating.
You can just leave it as 10 over 3. That's totally okay. So I'd like to give you another one to try. Is that okay?
Yeah.
Okay. So it's same problem, same situation. Domain 5x minus 1 square root, and I'll put a 3 here and a -6. Again, all of that's like window dressing. It's extra. You don't really care about it, but it is there. You just set the part under the root greater than or equal to 0.
5x So 5x greater than or equal, oh wait, 5x minus 1 greater than or equal to 0. Is that what you'd write?
Yes, just like that. Very
And
good.
then +1 +1. Wait, no, yeah. So it'd be 5x greater than or equal to 1. And then divide by 5. Divide by 5. So then it would be x is greater than or equal to 1/5.
Exactly. Feel like you got that?
Mm-hmm.
Perfect. All right. Okay, a small comment. No, I guess if you got it, so we don't need to, I don't need to overwhelm you with details. Is your math class first thing of the day,
Last period or
last period?
second. So second period technically.
Okay. Is that good or bad? Is that you feel awake
Yeah,
then or
it's probably better that I have it at the
okay,
end of the day.
great. I know this is a little hard to see here, but it's -2x². You do have a graph of this on the right. You remember how you graphed this, how you did it, and it's okay to just say I copied it down. I just want to know how much I
Oh, I
need to
copied the
explain.
graph down, but
Okay,
here,
okay, good.
let me check the thing. 40, which number 43?
Yes, 43.
I copied it down. I don't know.
That's okay. Just want to know where we're at. So one of the ways you can graph, and that's what I was going to actually bring up, is you can make a table. It's not real complicated. X, Y, we'll keep it super simple. We'll just make 3 points. Okay. So you have to put each of these values in for X. So the only way you can make a mistake here is if you don't evaluate properly with order of operations. Okay. So like, for example, for -1, it's -2 parentheses -1 squared. I'm putting -1 in for X. Now, order of operations says you first square, then multiply by -2. What would that become?
So that would be, wait, you first, so would you, okay. So then it'd be, that would just become 2.
You square, what is -1 squared? Start with that.
Oh, is it just 1?
It's just 1 times
Like
-2.
+1. Yeah, and then, so it's just -2.
Yes. Okay, so I'd like you to do the same thing for the other two values, please, and give me the results.
Okay. Wait. Let's see, sweet. Power of 2. So would be, the 0 would just be 0. And then the 1 would be no, -2.
Yes. Now, normally they want 5 points, but hey, it's a final. Just do 3. Three's good. And the graph of these, you can see now that it goes down like that. Okay. That's what you have, but now you've got a little better idea of how to do it. Okay. The next part is more important though. The next part asks you to identify the domain and range. Okay, do you remember anything about how to do domain?
Domain's the X value, right?
That's right. Now, for a line, for a quadratic, it's everything. It's everything. No exceptions. So that might be something to write down for a line, for quadratic. The domain is always all real numbers.
Okay. Wait, where's my sheet there? I think I might have that actually already down. Nope. Yes.
Let me know when you're ready for the range.
Wait, so is the domain just all real numbers? That's the answer.
It's everything. Yeah, it's all real numbers. There's no restrictions.
What's in the range? I know that
Range,
that's like the highest point to the negative point, at least on a
that's
line.
right. So because it's opening down, and this might be something to write down, it's always y less than or equal to if it opens down.
Zero.
It's y greater than or equal to.
Wait, no.
Yes, and
Opening down is minimum, and then opening up is maximum.
that's right.
So would the answer be y is wait, no, 0 is greater than or less than y, or could you just put min or max? Like
You have to write it this way with the y.
okay.
Y is less than or equal to 0. Because the way you would read it as a sentence, the way you tell me, you'd say it'd be all the numbers less than 0.
Okay.
Okay. Any questions on that?
No.
All right, so let's do 44. It's another graphing. We'll do the table thing again because I think that kind of revealed some things about how to actually evaluate quadratics and some good practice here. So we got x squared minus 9. And we're gonna graph this. So we're gonna graph 3 points. Let's just go -1, 0, and 1. So the -1 is like this: -1 squared minus 9. So you square that number, then you subtract 9.
That score would be 1, so 8.
-8.
Oh yeah. My bad.
Sign matters. It's like going the wrong way in sports. It's really bad. Try the next two, please, and give me your answers.
So the next one would be -9.
Yes,
And then the next one would be -8 again, I think.
you got it. So the really rough sketch of this thing is 0, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going up and up like that. Okay. Now this is not to scale. I mean, this is not, but it's going up. Okay. What is the domain of the quadratic?
All real numbers.
All real numbers. Good. How about the range?
Y is greater than or equal to 0.
Try again.
Y is greater.
It is greater than or equal to, but
yeah.
it's a different number.
Oh, is it 9? Negative? Wait.
Yes, it's always the y value of the vertex. So that's maybe something else to add here is that the numbers, these are the y values of the vertex. The min, or it's actually the min or the max.
Okay.
All right. So now this one asks for something slightly different though. It asks for where x squared minus 9 equals 0. And this kind of leads into the factoring stuff. There is a way to factor this, but you can also use what's called the square root property. Do you remember either of those?
Square root property.
Difference of squares or square root property? Either one will work here.
Square root. No. Wait,
Okay.
what was the first thing you said?
Difference of squares or the square root property?
No, it's not on my sheet.
Okay. I'm not sure which one to suggest here, but let's go through them both. So here is difference of squares. I'll just show you the answer and maybe that will clarify something.
Oh yeah, I know what that is.
Okay, so here's where it comes from.
Yeah.
It comes from if you have something squared minus something squared, the first something minus the second something.
Oh, that's rate of change.
No, this is difference of squares.
Oh. Looks like rate of change, kind of.
Kind of, yeah, it's, I mean. All right, so the reason your problem becomes x minus 3x plus 3 is because 9 can really be written as 3 squared. And that's where the x minus 3 and the x plus 3 come from. All right, so we're not quite done here, but do you follow kind of how I wrote this binomial times this binomial
Yeah.
from x? Okay, so you have to set each of those equal to 0.
And then that makes the one on the left positive,
That's right. Becomes
and then the
plus
one
3.
on the right would be negative.
You got it. So believe it or not, we got another one for you to try down here. So I'm gonna just change it up a little bit. Let me know when you get this down, or if
Oh,
I've got
sure.
it.
Yeah,
I'll give you one like this. You'll want to get this formula down and maybe the words difference of squares.
A2 minus B2 equals A minus, wait, that's plus A minus B, A plus I.
Got it?
Yeah.
Okay, so this is like 49 on your page. It says to factor, but we're gonna solve. We're gonna set x squared minus 121 equal to 0. Okay, so you have to figure out, what do you square, get back to 121?
11.
11, right. Now, this is your A, x, this is your B.
Okay. Would 0 be a C, or is there no C?
No, there is no C. If you go, like, what I'm trying to show you is that you have the A and the B to write in this formula right here.
Oh, so it's just the same formula, but like
Yes,
different ways of
exactly.
getting
So tell me what to write in parentheses down here.
it. X equals
No
no?
equals.
Oh, I mean, sorry, x minus 11, x plus 11.
Yes, good. So can you solve that for me?
So x equals 11, x equals negative 11.
Good. Okay, let me have you try one start to finish here. You could solve this, please.
Oh, so x equals 18. Wait, and then x.
Nope. Nope.
18?
Okay. I'm giving you a problem just like the one we just did. Like, don't follow the steps. You know, your coach tells you to like
Oh,
run the drill and then run it again and again. Like, that's what I'm asking you to
oh,
do. Just
oh, okay,
follow
okay.
these
So,
steps.
oh, then parenthesis x minus 18.
No, 18
No?
squared is not 36.
Is it not? Wait.
18 squared is like 376.
Oh, you're right. Hold on. I took the what's it called?
It's okay. Just
I didn't take
take
this
your time.
Okay. What's number 36? Square root 6. So x minus 6, x plus 6.
Okay, keep going.
And then x minus 6 equals 0, x plus 6 equals 0.
Okay.
And then
what's the
so
final answer?
x plus 6, x equals 6, x equals negative 6.
All right, good job.
Can't you
Okay.
also do oh wait, never mind.
This, can you take the square root of both sides? Like x squared equals 36.
No,
Like
I was
that.
thinking of something different.
Okay.
Never mind.
All right. It's okay. I do want you to interject. You are a good math student. We just got to get you, good skills back, and you're going to be in good shape here, heading into next year. Okay, so this one's a little bit different. You're looking for two numbers that multiply to 48. Okay, but they have to add, sorry, negative 48, add to negative 8. Multiply to negative 48, but add to negative 8.
Oh, so you make like a tree.
You make a tree, yes.
So x2 minus 8x minus 48. So 48 and 1, 2 and 24. I don't know the rest.
3 and 16,
3 and
4 and 12.
4 and 12. Oh, it would be, wouldn't it be negative 4
Yes.
and negative 12? I mean, I'll say
Right, so one of them has to be negative. It's either negative 4 and 12 or 4 and negative 12. Which one is it?
4 and negative 12.
This becomes x plus 4, x minus 12. Let's say you were setting it equal to 0. What would you do next?
So then it would be x equals negative 4, x equals positive 12.
Yes.
So if it was like two numbers, for example, like the number you're trying to get, you like 25, and then you took like the tree and got 5 and 5 or whatever.
Yes.
For example, could you do, instead of just doing the whole thing, could you just do like x plus 5 to the power of 2? Or
If there are certain situations where, like what you just asked is if you get x squared plus 10x plus 25, it would be x plus 5 times x plus 5, which
okay.
is
Then could you do
x plus 5.
Because I remember like in class where there's a few problems that ended out like that, and then I think there's some on the final, but like on the earlier pages. So.
Okay. Well, we are out of time, unfortunately. Did a great job. Here, I'm going to go and stop the recording.